Okay, so we've talked about this compound angular drilling, where we're going in and not only angling to the side, but also left and right, but up and down as well. Today we're going to take a little bit different look at it. What we've been doing is we've been giving you length, width, and height of those pieces. What we're going to do today we're going to look at the front view, end view, and if you're given this angle here, let's say that that is 32 degrees. And this angle here, we'll call that one 26 degrees. We'll find our angle of rotation. Now, there are ways that we can combine just the angles and make this. And I'll show you that in a little bit. But first thing I want to show you is like I handle this. There are certain times in math where we don't care about the raw numbers, we care about the ratios. This is one of those, where the raw numbers don't matter. The only place here that the raw numbers would matter if we're trying to find the length of that bore, the length of that hole. Cutting time calculation or that. But if we're just looking for the angles, all we care about is the ratio of those dimensions. So we don't care what the actual dimensions are, which means I can make up one of the dimensions and figure out what all the other dimensions would have to be based upon that. I might come in here and say this dimension here, 10 millimeters, just to make life easy on it. That's 10 millimeters. I can now come to these triangles and find this length and this length. Here, this would be the 10, 32 degrees. I'll call this dimension A here. How would I find dimension A there?
Tangent.
Got it. Tangent to 32 degrees equals A over 10 millimeters. Very good. Put that over 1. We'll cross multiply and divide to find A. Ends up being 6.249. This triangle over here, I'll call this dimension B. This is 10 millimeters. 26 degrees. How do we find B? Same thing. Tangent of 26 degrees. B over 10. That over 1, and we'll cross multiply and divide. Tangent of 26 times 10 divided by 1, 4.877. What this means now is it put it in the same form we were working with it yesterday. tend to do. If we draw this box, going from that upper back corner to lower front corner, this is our 10 millimeter thickness. 4.877 millimeters. This is the 6.249 millimeters. Now again, those aren't the actual sizes, but ratios are the same. So I can find my angle of rotation here by doing what? There we go. Inverse tangent of opposite side is 4.877 over adjacent side is 6.249. .97 degrees. That's my angle of rotation. My angle of tilt, we found up here, requires that we have the length of bore. Oh, we don't, this isn't the actual length of bore, but we can find it based on these dimensions. Square root of 10 squared plus 6.249 squared plus 4.877 squared. .761. Now, the only way that would actually be the length of bore is if we were given the thickness of the part. If we had been told that the part was 10 millimeters thick, then that actually would be the length of the bore. But we just guessed the 10, we chose the 10 millimeters to do the rest of the calculations. This is just a hypothetical length. But it does allow us to find our angle of tilt. It'll be the inverse cosine of our thickness, 10, divided by that length of bore. .41 degrees. You see, that took us about 8 or 9 minutes. Not bad. All we had to do was just look at this and say, hey, I can make up a thickness and go from there. Because when you're finding your angles with your trig functions, it's the ratio of the sides, not the actual length of the sides that matters. This preserves the ratio of those sides just by using those angles to find the length and the width after we guess the thickness. Now on the quiz I'm going to give you, I will give you the thickness, which means that that length of bore, this number here, actually is a real number. So just so you're aware of that. If I give you the thickness, or if you're given the actual thickness, that those numbers are actually legitimate. Those are the real numbers. What if you don't want to guess that thickness and go from there? What if you want a formula you can just plug stuff into? If you haven't figured out now after like 30 weeks with me, I hate formulas. I don't like to have to memorize stuff and do it. I like to be able to use my basic concepts and figure it out from there. Partly because, well, especially as I get older, my memory sucks. Give me till the 1st of June and I'll be lucky if I can remember most of your names, to be totally honest. Not to be mean. I've had a couple of classes, they walk in, I only see them twice a week, and I have to look at them and say, I know who you are, but what's your name? You know? So I don't like having to memorize anything more than I have to, because when you memorize something, there's a possibility you'll forget it. But if you understand the basic concepts, like what we just did, you can find it. But the formula for our angle of rotation, if you know given this angle, we'll call angle D. Angle we'll call angle D. This angle here I'll call angle B. Given those angles D and V, the angle of rotation is the inverse tangent of angle D Now this formula actually makes a lot of sense. I can make sure you got it down and I'll show you. If I go up here, it was the tangent of this angle that gave us this side here, right? This is just the tangent of the angle times the 10. It was the tangent of this angle that gave us this side here. It was just the tangent of that angle times 10 again. And then we went this over this inverse tangent to get that angle of rotation. Well, this is just 10 times the tangent, and this is 10 times the other tangent. So putting those tangents in there, I'm just avoiding multiplying by a thickness, which is, I made up that thickness anyway. That makes sense. The angle of tilt, a little more complex. We use the inverse tangent of the square root of tangent of d. How does that come into anything? Well, what they're doing is this. Instead of using the length of bore here and the height, they're using the height and this length across here. This is the tangent of d times 10. This is the tangent of b times 10. This squared plus this squared equals that squared, right? That's what this represents. Tangent of d squared plus tangent of b squared square rooted represents that length. Inverse tangent of that technically should be that over 1. They're assuming, they're calling the height. What they've done in this example is instead of picking the height to be 10 like I did, I chose 10 so that I don't have big decimals. They chose it to be 1, what they did. So being over 1, the inverse tangent, according to this angle right here, this is the opposite side, that's the adjacent side, so doing it inverse. So it does make sense. You can see where it comes from. It's just, if you were going to derive these formulas to use them, it's easier just to pick a number and put it in there for the thickness, go from there, rather than just trying to derive the formulas to use. So let's do this example. What did I say? D was 32 and E was 26, yes. So, our angle of rotation is the inverse tangent of tangent of 32 degrees second tangent. Tangent of 32, you gotta remember to close that parentheses, divided by tangent of 26. Now you gotta remember to close the parentheses twice, so the calculator knows that all of that is inside the inverse tangent. I get 52.03 degrees. So the angle they're giving here, I flipped that over, I bet I did. I flipped over my thing. Complement of that. So they're giving this angle here. Right there is the angle of rotation. So they're just rotating the other direction is all they're doing. Let's find my angle of tilt. Tangent of the square root of tangent of 32 squared plus tangent of 26. This one's a little trickier to enter in the calculator. Just a second. Tangent of 32, you gotta close the parentheses and then hit x squared, and that'll be fine. Plus tangent of 26, close the parentheses, hit x squared. Then close your parentheses on the inverse tangent. 32.14 degrees. For that to what we had. 38.41. Usually these come out exact, so I'm having a rough day today. Let me see if I entered it correct. Let me do this just to make sure things. Oh, I forgot the square root, that's why. Second tangent, second square root. That'll make a difference. Tangent of 32, close the parentheses squared, plus tangent of 26, close the parentheses squared, close the square root, and close the inverse tangent. 38.4, that's what we had. 38.41. Oh. I'm actually kind of glad I made that mistake. We did come out to within 1/100th of a degree of being the same angle. But you see, that's not an easy formula to enter in the calculator. I screwed it up the first time entering it. A lot of pieces to go in there. The biggest mistake people make is they don't get enough parentheses to close at the end there. If you don't get all those parentheses in there to close it up, the calculator can interpret the whole equation incorrectly. It causes issues. That do anything terribly new today. Out of the packet, page 401 through 404. 1 through 15, the odds deals with finding the angle of rotation and tilt from your, just the angles. Now remember, your angle of rotation, if you get something that's the complement of what they have, that just means you rotated it the other way. There are two different ways you can rotate.